is another lesson on the atomic number and mass number on the periodic table. So we are still recapping all of our previous work and checking our understanding of atomic structure. Looking at the progress questions that we want to be answering today. First thing is being able to explain why most of the mass of the atom is found in its nucleus. Second point is, what does the atomic number tell you about the element? And the third thing, how can you calculate the number of protons, neutrons and electrons in an atom? So today's lesson is mainly about the periodic table. So it would be handy if you have your periodic table with you. It might be up on screen or it might be in one of your revision guides. Okay, starting off, we're going to have a look at quite an experiment, which is the gold leaf experiment. Now, in this diagram, you can see that Rutherford and his team conducted an experiment where tiny positive particles were fired at a thin sheet of gold. Now, most of those particles passed straight through the gold foil. Now, based on those results, that would suggest that even though there was lots of matter there, that matter was made up of atoms, but most of that atom was empty space. Because if it wasn't empty space, those tiny particles would have collided with something and either been deflected or completely bounced back. Whereas you can see clearly in that diagram that most of the particles passed straight through the gold foil, suggesting that the atom was mainly made up of empty space. Some of the particles did fire back, but very few, and that would be when they hit directly the nucleus, showing that that mass was concentrated in the centre of the atom. Now, if we look at all the information we can get from the periodic table, here's an example of an element. So we've got sodium here. Now, you get given the periodic table in your exam. The periodic table has lots and lots of answers in it. You just have to be able to access that information. So, if you see here, we've got sodium. The first thing that it shows us is the symbol for sodium. So in this case, we can see it written down as Na. Then we have a mass number at the top. The mass number is the largest of the two numbers. Sometimes on different periodic tables, you might see the numbers are written in a different order. So the mass number might be at the top, or sometimes it might be at the bottom. The key thing to remember is the mass number is always the larger number. The bottom number is the atomic number. Now, we'll deal with that first of all because that's the one that gives us a nice simple set of information. So the atomic number simply refers to the number of protons in one atom of that element. So inside an atom of sodium, you will have 11 protons. Straightforward. Now, in our previous lesson, we said that in an atom has no overall charge, so the number of protons is equal to the number of electrons. So we can now get two pieces of information from that atomic number. We know that there are 11 protons, and if there are 11 protons, there must also be 11 electrons. So far, out of the three things that we need to be able to talk about, which is protons, electrons, and neutrons, we can say sodium has 11 protons. We can say it has 11 electrons, but now we need to be able to work out how many neutrons there are. So this is where we use the mass number. The mass number refers to the mass of the atom. The two particles that have some mass are protons and neutrons. So to work out the number of neutrons, we take the mass number, in this case 23, and subtract 11 from it. So that will give us 12. So we know that there will be 12 neutrons in sodium. Now the way to have a look at that is to try and have a go at one of these styles of questions. And again, we've done lots and lots of these in class. So there are two atoms here, X and Y. We know the atomic number of each one of them, and we know the number of protons. And you'll notice the number of protons is the same as the atomic number. We've got the number of neutrons, and we've got the number of electrons. Now, we need to be able to fill in those gaps. So if you want to spend a couple of minutes, pause the video, have a go at that question, and then we'll have a look through the answers. Okay, if I just show you the answers here. So, first one, we have atom X. Atom X has 90 for the atomic number. 222 is the mass number. It has 90 protons and 132 neutrons. We don't know the number of electrons, but with all the information we've got, we know an atom will always have the same number of electrons as protons because an atom does not have an overall charge. So the answer must be 90. Moving on to atom Y, we know the atomic number is 88, but we don't know the mass number. So this is testing our understanding that we know the mass number is made up of the two particles that have mass inside the atom, and that is the protons and the neutrons. So to work out the mass number, we simply need to add the number of protons and the number of neutrons together, giving us 222. These questions frequently come up in exam papers, and it's just a matter of making sure you learn those two simple rules, that the proton number tells you the number of protons, and protons will always equal the number of electrons, and the mass number tells you the number of protons and neutrons combined, so you will need to do mass number take away atomic number to tell you how many neutrons you have in an atom. Now, okay, that will go away in a minute. Okay, so what we're going to do is have a look at some of the extension questions now and see how we get on. If we just wait while that loads up. So again, in today's lesson, I will have put some tasks up for you to do in the assignment section, but if any of you want to really push yourselves further, you can have a go at the extend section on this question. Just pause the video, write it down, and then send it in to me and I will mark it for you and see how you've got on. But there will be other questions based in the assignment as well. Thank you very much, and I look forward to seeing you next time.